Namaste, Andargi Namaskaramulu, Subhodaya, Namo Namaha. Today is the 27th day of our webinars on Sanatana Dharma. We have already finished 1 month of our course, classwork, and the second month is going on. In the second month, we started with a very important topic, that is Vedic mathematics. And today is the 5th day of Vedic mathematics. And from Monday onwards, we are going to have Sanatana Dharma Shodasa Samskaramulu by Dr. Visalakshi Garu, who is our Vice President Sanatana Dharma. Then later on, we'll go for Ramayanam, Mahabharatam, and some research topics and Vastu, etc. Okay, now let us start with Vande Mataram by B. Ramachandra Murthy Garu. And then we will go for Prarthana by Ananthanji. Then we will start with webinar by Guruji. Okay, let us start with, all of you please stand up and sing along with Ramachandra Murthy Garu.
Vande Mataram, Vande Mataram, Sujalam Supalam,
Layajasita Satyashyamalam Mataram.
Vande Mataram, Subrajotsna Pulakitayamini, Pulla Kusumita Dhrumadala Sobhini, Subhasini, Sumadhura Bhashini, Sukhadam Varadam Mataram, Vande Mataram, Subrajotsna Pulakitayamini, Pulla Kusumita Dhrumadala Sobhini, Suhasini, Sumadhura Bhashini, Sukhadam Varadam Mataram, Vande Mataram, Vande Mataram.
Oh, somebody muted me. So, Vande Mataram. Dhanyavadaha. Let us have Ananthanji. Namaste. Please do Prarthana for us. Yeah. Okay, please.
Om. 1 minute meditation. Relax. Close the eyes gently. Observe full body. Wherever you feel pain, take your mind there so that pain goes. By observing, the pain goes. Feel energetic. Give auto suggestion to mind. Next 2 hours, you will not entertain any other thought. other than the clause. Om. 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 Gananantva Ganapatigum Havamahe Kavim Kavinamupamashravastamam Jeshtarajam Brahmanam Brahmanaspata Anashunvannoti Dasadanam Mahaganapataye Namaha Prano Devi Saraswati Vajebirvajinivati Dhinamavitriyavatu Vagdevyai Namaha Gurureva Gatir Gurumeva Bhaje Gurunaiva Sahasmi Namo Gurave Na Guroh Paramam Shishurasmi Guroho Matirasti Gurau Mama Pahi Guru Jnananandamayan Devam Nirmalaspatikakrutim Adharam Sarva Vidyanam Hayagrivam Shruti Smruti Purananamalayam Karunalayam Namami Bhagavat Pada Shankaram Loka Shankaram Shankaram Shankaracharyam Keshavam Badarayanam Sutra Bhashya Krutau Vande Bhagavantau Punah Punaha Ishvaro Gururatmeti Murti Bheda Vibhagine Vyomavat Vyapta Dehaya Dakshinamurtaye Namaha Om Sahana Vavatu Sahano Bhunaktu Sahabiryankaravavahai Tejasvinavaditamastu ma vidvishavahai Om Shanti Shanti Shantihi Harihi Om Shri Gurubhyo Namaha Harihi Om Namaskar.
Dhanyavada Anantanji. Now let us request Guruji to start the webinar, please.
Namaskar. Yesterday we finished here that what is the periodicity of the recurring decimal, and today I covered the divisibility rule. And if time is left, we can discuss on any particular topics, revision or any question, any doubt. Now, as you know that for the components of 10, because we have decimal system, here the components of decimal means 10 is 2 and 5. So therefore, there is a very easy divisibility rule for 2 and powers of 2 and 5 and powers of 5. It is like this. Divisibility by 2 to the power n requires last n digits to be divisible by 2 to the power n. The 57356 is divisible by 4 because 56 is divisible by 4. So as many of the power of the 2, you take as many of the last digits. That is, if that is divisible, the whole thing will be divisible. Similarly, for 5 and 5 to the power anything, 5 to the power n, the last n digits to be divisible by 5. So this particular number, at the last there is 75 is divisible by 25, since 75 is divisible by 25, like this. divisibility by a composite number which is mixed with these powers of 2 and 5 and with other numbers like that I listed 135 ending in 1357, 1379. Those actually are will be done like that. Any composite number, the divisibility by its factors. Like 42 is divisible by 6 because it is divisible by 2 as well as it is divisible by 3. 135 is divisible by 15 because it is divisible by 3 as well as 5. It is about the composite numbers comprising of 1379 and a power of 2 and or 5, 2 and or 5. Divisibility by numbers ending with 1379 has general method of osculation. This osculation method will try and which gets trivial form in the case of 3, 9 and 11 because their oscillator is +1 and -1 respectively. We'll learn this osculation, then we'll find that those are so obvious because their oscillators are only 1 and -1, so it becomes a very obvious form. Otherwise, in general, there will be a particular formula for osculation. Now, divisible by 3, what do we know? The number is divisible by 3 if sum of all its digits sum is divisible by 3. So, for example, this is if you sum all the numbers of 5, 4, 2, 3, 5, 4, 5, all that should be, it is 24 and divisible by 3. So, the whole number is divisible by 3. Similarly, same rule for divisibility 9 because those have same oscillator 1. A number is divisible by 9 if sum of all its digits is divisible by 9. For example, this large number of 7 digits is divisible by 9 because it is a sum of all the numbers are 27 and divisible by 9. Divisibility of 11 because 11 contains the oscillator -1, so it is alternatively see plus and minus. A number is divisible by 11 if the difference of sums of alternative digits, say even an odd position number, is 0 or it's divisible by 11. For example, the number 934571 is divisible by 11 because if we alternatively it will sum 9 plus 4 plus 7 and on the other hand 3 plus 5 plus 1. We sum them and difference them. It becomes 20 minus 9, which is 11 and divisible by 11. Or even if it is 0 matching, then also the two sums are matching. Even then it will be divisible by 11. Exercise. Find whether the number is divisible by 3, 9 or 11. You can easily do it. Now, what is the general method of osculation? Why these 3, 9, 11 are behaving that way? We come first the proof. Actually, I started with the algebra so that it becomes you come to know that what is the method actually. A 2 or more digit number n can be expressed in the form n is equal to 10r plus u, where u is the unit digits and r is the rest digits, comprising of 10 digits and beyond, all 10s, 100, 1000, all clubbed together, and becomes r. So 10 into r we are doing and unit digit you are using, adding so that it becomes the actual number. Osculation is a basic method to create a smaller number, smaller integer t is equal to r plus mu. We multiply something, some m. That m has to be first, we have to see what is the m. M has to be multiplied by unit digits and added to r. So earlier it was 10r, now it is r only. So obviously it will be smaller. And where the multiplier m is also called the osculator. It is being said that the integer n is osculated by small m to get t. The process can be recursive with the oscillator m. That means some t is there and t also will have in the form 10r plus u form. Again, that unit digit you multiplied by m and add with the rest so that you get the next level of t. To get t, now the process can be recursive with the same oscillator m. That is, unit digits of t can be multiplied with m and added to rest of the digits t. Osculation is in an efficient method for testing divisibility. It is a matter to determine the required m given a number n and a divisor d ending in 1, 3, 7 or 9. The oscillator m can be found with the following process. Now, this anything 1379 ends, it is the general condition whether the number is a prime or a composite. Considering m into n minus t. Now this is a side by side. If you can, even you can also try. Of course, these are available. Presentation is available, but somewhere you can do some rough calculation. You have pen, paper, and so on. Now mn minus t is m into n was 10r plus u, and minus t is r plus mu. That is the definition of t. Now, if we just do some algebraic this thing, so it becomes 10 mr plus mu minus r minus mu. That means mn minus t is actually 10m minus 1 r. This 10m minus 1 is a very important thing. Let us consider the case of divisibility by a number, say that is divisor d. If we can find an oscillator m such that 10m minus 1 mod d is 0, that means 10m minus 1 is divisible by d, so that this from equation 1 we will find that mn minus t will be divisible by d, and mn minus t divisible by d, and if this is found, so when this is found, what will happen? And then we test the divisibility of t only. Now mn minus t divisible by d, and if the t is found divisible by d, then sum of two divisible become again divisible. So if t is divisible, mn minus t will be of course divisible. Sum or addition. So in divisibility, there is a peculiar condition. I didn't write it here. A divisible into divisible or non-divisible will be divisible. Any multiplication with the integer multiplication of a divisible will be divisible. That is a multiplication. About addition, if two divisibles are there, when they are added, that addition or subtraction also will be divisible. However, if one is divisible, another is undivisible, and we are doing it plus or minus, subtraction or addition, that will not be divisible. But in case of both are undivisible, and then we subtract or add that is actually indeterminate. We cannot determine that may be divisible or not divisible. But here I find that t, I have to find that t is divisible or t is not divisible. Now, divisibility or not divisibility of t will determine the divisibility of this part. That is the thing. Because if this is divisible and this is not divisible, so both things will not be divisible. So that if now I find that this is not divisible, that means this whole thing is divisible. That means either both should be divisible or none should be divisible. That's what I want to say. So we have to only test the divisibility with t, that will determine the divisibility with n. So I repeat it here. Now, once the proper oscillator, this oscillator of m is found, and 10m minus 1 is divisible by d. From this equation, I found that this will imply mn minus t also divisible by d. And so, if I get a t where it is divisible by d, so this will imply mn minus mn also divisible by d, and therefore, because m is not divisible by d, because I have written here, because m we have found that 10m minus 1 was divisible by d, so that m cannot be divisible by d, because 10 again was not divisible by d, and so this is some logic here. Now I come to the practical thing, how to do it. Now I have to test whether the number 343 is divisible by 7. First we have found, first we have to find the oscillator of for 7. We see that either 10 into 5 minus 1 is divisible by 7, that is 49 is divisible by 7, or I'll see the another one, and thus oscillator of m is oscillator for 7 is 5. Then we have to do process with 5, and then we have to do 343. We do 34. We separate out. It is the R part, and then this is the 3 is U part and unit part. U into 5. That oscillator is, we have found that m is 5, small m. It becomes 15 plus 34 is 49. It is divisible by 7. If you suppose, even if this also you can do, but it is no point. 9 into 5 is 30. Your 45 plus 4 again comes back to 49. So it doesn't matter. You can, this 2-digit number you can easily see it is divisible by 7. So therefore 343 is divisible by 7. Take this 6, 4, 7 to 4. 6 to 7 4 6 4 7 2 plus 4 into 5 becomes 6 4 9 2. This becomes 6 4 9 plus 2 into 5 is 659. Again 65 plus 9 into 5 is 110, and 100 plus 0 into 5 is 11. Not divisible by 7. So therefore, backtracking will find that none of these numbers, including this number, original 6 4 75, none are divisible by 7. Take the case of 13. Now 13.
Excuse me, sir.
Yes.
Can you please explain that previous number, previous slide? 343. You have written 34 plus 3 into 5. How did you get this 3 into 5?
Yeah, because in case of 7, we find that there is a number 10 into 5 minus 1, that is 49, is divisible by 7.
Okay.
10m minus 1 should be divisible by the d,
Yes.
7. So therefore, as soon as you find that, and if I, that becomes my oscillator. This 5 becomes my oscillator.
Okay.
Now with the oscillator, we'll use like that. We take the rest of the digit and add the unit digit into that oscillator with that the rest of the digit.
Oh, unit.
34
Okay.
plus 3 into 5.
3 into 5. Okay.
Because 10 into 5 minus 1 is divisible by 7. That is the criteria. Okay, this algebra I have given here, the proof of that. So if we find a number so that the 10 times of that minus 1 is divisible by 7, that our divisor in this case, so then we can do like this. We can oscillate with the help of that number 5. Oscillate means take the rest number and then unit digit you will multiply with that oscillator and then give the total. If the total is divisible by 7, it becomes divisible by 7. Okay. So this also I tested and it's not divisible. Now let's take another case of another case of 13. Now 13, how to find the oscillator? Now I find that 10 into 4 minus 1, that is 39, is divisible by 13. So in case of 13, m is 4. Value of this oscillator is 4. So we do what do we do? 11635 goes to 1163 plus 5 into 4. This 4 is the oscillator. This 5 was here, 4 is the oscillator. We are multiplying the unit digits with oscillator. It becomes 1183. Then again 118 we take, and again this oscillator is multiplied with the unit digit. It becomes 130, and then 13 plus 0 into 4 is 13. So therefore, 130 also you could have shown directly that 130 is divisible by 13. So, but again you can do it or not do, that matter. Since it is therefore it is 130, 1183, 1163, everything are divisible by 13. When you are getting the last digit as 0, you can leave it there, no problem. Because in any case 10 is not divisible by 7, so 110 means 11 is also not divisible by 7 in this case. And if 130 is divisible, means 13 is, of course, it is divisible by 13. So therefore, all the backtracking, all the numbers will be, this could have been even larger number, or there could have been more steps. The larger the number, the larger number of steps will be there. And then finally it goes to divisible by 13.
So Goutham ji, to find out the M, so we have to try with every 1 to 9, we have to find every number, right?
Oh, right.
Yeah. Okay.
Yes.
There is no other easy way, right?
Something ending in 9 should be divisible by that your divisor. Take a divisor. You find something which is ending in 9. No, not difficult actually. 7 into 7 means actually if we multiply by 7, it becomes ending 9. If something is ending in 3, if we if we multiply by 3, it will be ending in 9. You don't have to do so many trials.
For this
Now, understand what
23, for this
Huh.
like
Yeah.
41,285 with 23, you can
Yes,
just figure.
let me answer your first question, that if something is ending, anything ending in 7, if we multiply that thing by 7, it ends in 9. So find that number and find it that what actually should be aimed by, because this 10 times something minus 1 will be that number. So you can find the aim. You understand what I'm telling?
Okay. So 7
anything
times.
ending in 7 has to be multiplied by 7 to get this positive oscillator. Anything ending in 3 must be multiplied with 3 first to get that something ending in 9. Then in case of 23, in case of 23 multiplied by 3, get 69.
320.
And 69 and get, it is find that, then you have to find that what is that oscillator. 10 times something minus 1 will be ending in 9, of course. So what is the 69? The 10 times 7 minus 1. That is to find out. You have to multiply with 3 and then find that. So 10 into 7 minus 1, in case of 23, it becomes 7. So 41285, 4128 plus 5 into 7, it goes like this. Again, 416 plus 3 into 7, it goes to this. Again, 43 plus 7 into 7, 92. Again, 9 plus 27 is 23. Or 92 itself, if you see that, okay, 92, I know that it is. When it becomes 2 digit, very easily you can see that it is divisible or not divisible.
Okay, in this case, if it is like 41,285 is divisible by, like for example, 21. Think if it is a 21, then also we will find it's like a 9 or something, like 10 times 9 minus, or no, 10 times. Oh, it's again divisible by 3. Okay, 21 is divisible by 3, so I can go with that 7. Okay, got it. Thank you. Right? If it is a 21, how do you do this one?
Gautamji, you are muted.
Not audible.
Negative and minimum oscillator. So far we have done only positive oscillator. Now if 10 plus 1, is there any problem in my internet connection? It says that. But
You were muted. Now we are okay. Now we are.
If 10 plus 1 is divisible by D, all the algebraic condition holds good for oscillator minus M. The same thing can be done with T should be calculated as R minus MU. In this case, minus M can be called a negative oscillator. I mean, M minus M, or algebraically you can say. Moreover, if M is an oscillator to test divisibility by D, M plus any factor, A plus or minus any factor of D also will be an oscillator, where F is any integer. This we try, we can not. It is telling that suppose M is a oscillator of 7. So sorry, 5 is a oscillator for 7. We got earlier. So 5 minus 7 means minus 2 also will be the oscillator. There is another reason why I come to directly. You can come to the negative oscillator concept. Example: 10 into 5 minus 1 was divisible by 7, but 10 into 2 plus 1 is divisible by 7. Thus, M is the minimum positive oscillator for oscillator, and minus 2 is the minimum negative oscillator as well as minimum oscillator for 7. In case of positive side is 5, 12, 19, and negative side minus 2, minus 9, minus 16. All can be used as testing divisibility, but when we can use by 5, why to use 12, 19? If we can use minus 2, why to use -9 and -16. Table of the next page gives the list of oscillators. Oscillator for 3 and 9 is +1 and 11 is -1. That is why their rule is very simple. Very obvious kind of thing which are taught in their childhood, since childhood, but about 7 and 13, those are skipped. Now we come to a table of oscillators. You understand, first I come to here, oscillator, negative oscillator, and then I will come to the table. Earlier I was, what I did earlier, now last digit I was multiplying by 5 and then adding. Here we find the negative oscillator for 7 is 2, because 10 into 2 plus 1, that is 21, as we told 21. So same rule will hold for 21, is divisible by 7. So negative oscillator of 7 is -2. We do the following. From 842912, we do 8429 minus 2 by 2. This 2 is the oscillator. So if this sign is plus, then oscillators, this will be minus, and so on. Earlier we did, this was minus in case of oscillator 5, and we were adding, but now you're subtracting. It will be even less. 842987. This goes to 8428 minus 7 by 2 again, and 8412. 841 4 into minus 4 into 2 because 833. 833 minus 2 it becomes 77. So 77 is divisible, therefore. So 833 or backtracking everything, and this also gets divided by 7. Note that for divisor ending in 1 or 7, it will be easier to use negative oscillator. In case of my earlier the recurring decimal case also, we find that something is ending in 1, we do a separate process. Exactly here also, because if we want to multiply by 9, it will become a very huge number. So you have to divide by a lot of things. So similarly, 21, I can get another number. See, this I can say this 77 is not divisible by 21. So therefore, 842912 also will not be divisible by 21. You told about 21, so I'm telling that. So rule of 21 and 7 are similar. If after doing all the oscillation, the result is divisible by 7, it will be divisible by 7. It is divisible by 21, divisible by 21. Of course, if it is divisible by 21, it will be divisible by 7 also. But if it is, sometimes it may happen like here, 77 is divisible by 7, but not divisible by 21.
Not by 21.
This will not be divisible by 21. Had it been, say, 63, here, suppose after doing all these things, it comes to 63. 63. Then 63 will be divisible by, are you getting network?
7.
My screen got low.
No, it is there, sir. It is normal.
Because it is giving some message actually. Therefore, so we understood. Had it been, say, suppose it comes to 63. Now 63 is divisible by 21. So this whole thing number would have been divisible by 21. Note that for divisor ending in 1 or 7, it will be easier to use negative oscillator instead of positive oscillator. In case of something ending in 3 or what is the other one? 3 or 9. 9 is, of course, you don't have to do anything. It is just the next number is that 19, for example. What is the oscillator for 19? You tell me now. If you want to do test something divisibility of which 19, what
-2?
9.
Yeah.
9.
No.
2.
It's 2. 2.
20 minus 1. So 2 into 10. 2 is the oscillator, positive oscillator.
Okay. Because this so it becomes. No, but it's for minimum positive becomes positive oscillator becomes 19 because I was talking of 21. But what you told in case of 19, what is that? Somebody answered correctly, no?
2.
In case
Two,
of
right?
19,
Yeah.
it is plus 2 or minus 2?
Minus 2.
Plus 2.
Plus 2.
Plus 2. 2 into 10 minus 1
Minus 1.
is 19. So it
So
is
in
plus
case
2.
of 19, in case of 7 or 21, this is minus 2. In case of 7 or 21, oscillator is minus 2. Okay. But in case of 19, here I am talking about 19 for a different context. Not that I'm not talking about the oscillator of 19 here. We discussed about the had it been we do not know some concept of negative oscillator, then we would have ended in for 21 we would have ended in oscillator of 19, positive oscillator. But in case of 19 the oscillator is plus 2, isn't it? So I didn't give the example. Let me see. No, here I didn't do because I thought that I'll go to white screen. Suppose you take a number, say, let me. You also do exercise. Suppose. So, suppose I take 1, 2, 6, 5, 4. Okay. Now I want to test whether divisible by 19. How I proceed? Please tell me. First, we found the oscillator of 19 because 2 into 10 minus 1 is divisible by 19, 19 itself. So the oscillator is plus 2. Now how to proceed this one? Please tell me. Next number. What I do? You are listening?
Yes, they are listening. I think one of them will respond. Please respond, no?
1265 plus 4 into 2.
Yeah. 1265.
Plus 8 means like 8, like it's 1273.
4 into 2 becomes 1273. Then what do you do?
127 plus 3 times 2.
127 plus 3 times 2.
It's 131. Sorry, 133.
133. This itself from 19 stable you can know, or you can do, if you are not satisfied, you can further do 13 plus
2, 3 into 2.
3 into 2.
65 plus 4 into 2, 1271. 1265 plus 4 into 2. It comes to 1271, I think.
1273. It's
65 plus
4 times 2 is 8. 8 plus 5 is 13.
the second step.
So one is with arrow, you write that from that you are doing escalation and they will equal to, because this you have to evaluate. Then again you do next step. So with arrow, so this is alternate arrow and equal to, arrow and equal to. So arrow, this here, from here it goes, you cannot write equal to because it goes to the process. Arrow means this process and then equal to means that evaluation. So 19 it comes, so that this whole thing is, all these numbers are divisible
Whole
by
number is
19.
divisible by 19.
Any doubt? Yeah, easy, isn't it? No problem.
Yes.
Yes. Now what I was telling that now this is a table of positive and negative oscillators. Just have a study. Okay, are you seeing the whole screen? n. N 1, 2, 3, 4, 5, 6, etc. Now I find the 10n, 10 types of n. 10 times of n. Now on the left, we have 10n minus 1. On the right, we have 10n plus 1. So 19, 11, 19, 20, 21, 29, 30, 31. All this number itself or its factors will have this oscillator as positive. So in case of, because 9 is 10 minus 1. So 9 oscillator is 1. So therefore, unit digit multiplying with 1 and adding rest. So equivalent to adding all the digits. So from childhood, we are taught that sum all the digits. If the sum is divisible by 9, the whole thing will be divisible by 9 or 3.
Yes.
But we didn't know that what is the background behind. Background is this oscillator procedure. In case of 9, it is plus 1. So it became so obvious that it add all the digits. But in case of 7, it became something. In case of 19, it is just multiplied by 2. We didn't learn that. I find it very peculiar. Now, why it is so that we learned 9 and 11 actually is minus 1 is the oscillator. 11 is 10n plus 1. So the oscillator is negative. So always you are doing negative to the unit digit you are adding that equivalent to alternatively alternative sum. The alternative sum is coming from this consideration. Anyway, so here the 19 is this 2 and 21 also minus 2. And 21's factors are 7 and 7. And of course, 3 for 3 you do not use that. So you do not use 3 because 3 is already there here. In case of 29, it is 3 plus 3. And in case of 31, it is minus 3. Both are prime, so there is no factors. And in case of 39 or 13, this is 4 because 39. And 41, of course, is prime, so it is 41 is plus 4 is the minus 4 is the oscillator for 41 and plus 4 for 13 or 39. So likewise, earlier we told, first we discussed this one. So in case of 7 or 70, 49, this is minus plus 5. And in case of 51 or 17, the 17 we get the new. For 17, it is actually better to use minus 5. Earlier we use plus 5 for 7 and for 17 it is minus 5. So likewise it goes. And suppose you want to do divisibility about 11 need not be considered. Just for sake of completeness, I did 11 already there is such obvious. You do not use like this. So 33 this way and 101 and so on. And this is 43. You have to do 43. It becomes a little higher. You do not get that much good taste. Actually, it oscillator becomes 13 in case of 43. In case of 17, it becomes 12. Oh, sorry. 12 is positive, but 17 we got already as minus 1, minus 5 we got in case of 17. So this is clear?
Can you show that minus 5, like with 17?
Yeah. So tell me a number, I take a number. So number 11322. I want to test whether it is divisible by 17 or not. Okay. What you do? Now 17 3 into 3 is equal to 51, which is 10 into 5 plus 1. Because this is plus, this oscillator becomes minus 5. This way I start. So this goes to, you tell me, please. What should I do?
113132 plus 2 into -5.
I directly do 2 into
Yeah.
minus 2 into 5.
Yes, minus 10.
It becomes 11 equal to 1 arrow and 1 equal to 11.
1122.
Again, I go arrow. What to do?
112.
See how fast they are converging with negative
Yeah.
oscillator.
Yeah, it's 10 again, 2 times 5. Okay, 110. Yeah, it's 51 times 2. Yeah.
And I know that 100 could already divisible by 17. Anyway, if you do not understand, remember the tables, you do next 10 minus
Minus 2 times 5.
Either it should be 0 or divisible by. So it is also
Okay.
0.
0.
0 means will also mean
It's a divisible by 51.
all are backtracking, everything is are divisible by. Suppose you change the number, suppose I make it 3. So obviously you'll get all the minus 3, this all goes to minus 3, and so everything, something will be there different, and the minus 3, and finally you'll get that it is not divisible by 17. So this is the idea. So with this one, it will, and with this one, I got using negative oscillator. Now exercises, you can do it in the home as homework. You can all do these things. Now I come to divisibility, multiplex oscillator method. Now again, I prove that an n+1 or higher digit number integer n can be expressed in the form n plus 10 to the power n r plus un, where un is the block of n numbers of digits towards unit digit and r is the rest. Actually, earlier what I saw earlier was small n was 1, the special case, but it can be also multiple. Multiplex oscillator is the basic method to create a smaller integer t plus r m with un. Here the multiplier m is now called the nth order multiplex oscillator. The process can be recursive and this same multiplex oscillator m. Oscillation is an efficient way, although I repeated actually, it is a matter of determining the n with dividing, the ending in 1379 and so on. Now consider mn minus t. Mn minus t is equal to m into 10 to the power r into into the power n into r plus u block of un blocks. I wanted to say that it same consideration holds good. And finally, if we find that 10 to the power n, so any power of n, power of 10 into m minus 1 is divisible by d. That means mn minus t also will be divisible by t, or t will be and t is divisible, mn also will be divisible by t. I give the multiplex oscillator. For divisor of the form 199, see, we are getting, now we are handling large numbers. Earlier, what we would have done that 199 from my earlier consideration, what would have been the oscillator for 199? It would have been 20, because 20 into 10 from my earlier learning, if I want to do oscillator for 199, what to do? I find that 20 into 10 20 into 10 minus 1, which is 199, isn't it? But 10 into 20, and I did wrote it first. 20 into 10 minus 1. So 20 becomes my oscillator in case of 199. And always multiplying 20, it's not required. That we can do it like that. We take oscillator as 20, 30, 40, etc. Instead of these simple oscillators, let us take a case of, we may also take 2, 3, 4 as multiple oscillator and take 2 digits at a time. That is the idea. Let us check whether the 2196155 is divisible by 29 to 29. Second order oscillator of 229 is 3, because 10 to the power 10 to the power 2 into 3 minus 1 is equal to 299. 299, sorry. 299 comes how? 10 square into 3 minus 1. So now this is the order. So second order oscillator of 229 is plus 3, because it is minus, this is plus 3. So this is the idea. So how to do? 2196155 is divisible by 299. The second order oscillator is 3. So first we write dividend in the groups of 2. That means from the right. We write 55, 61. Earlier it was only a block of 1. We didn't notice that. And 2, of course, 2. Single, or it can be double. Now from 219, the next state becomes arrow. Arrow means it goes to oscillator. 21961, and we are handling 55 altogether. 55 into 3. So it becomes 22126. From this one, you can do it. 221 plus 26 into 3 is 299 divisible. See, such a big number got collapsed with this multiplex oscillator method. Such a big number gets collapsed immediately and comes to result. That it is divisible. 3 is 229. This is also divisible. This is also divisible, and this is also divisible by 299. Such a big number. See, whether it is divisible by 499 or not. We first group it into group into 2. Group into 2 from the right. So 10, 66, 56, 87, 42, and then last was 69. We actually group into 2, cut this one first. That is sufficient. And cut this number and then multiply by 5, because this is actually 499. I was considering by 499. So 499 plus 1 is 500. That means 5 into 10 square. So second order oscillator for 499 is plus 5. So 69 into 5. So this becomes this. Again, we this becomes group into this. This is cut actually. Last 2 digits are cut. So this into 87 into 5 becomes this one. I didn't write the intermediate steps. This plus this is already I did. And again we cut the last 2 digits. So this becomes this plus this one, and this one. This from this one again I do last cut the 2 digits. See how fast it is collapsing. It is depend upon the number of. So this into 5 again. This 1497 and becomes this. This again I actually cut here. This 499. That's this all the bracket numbers, including this actual number, is divisible by 499. Now multiple oscillator. This by 401. Again that I consider. This is in case of this is negative 401. So this is actually 10 square
Multiplied by n plus 1.
Into 4.
4, yeah.
Into 5. Sorry, into 4. 4 is here. Into 4 minus plus 1. So we call it second order oscillator of 401 is minus 4. Minus 4. Because of this is plus. So 1 to this I cut this 32. So this into 4 minus this into 4, because this again I cut it here. Again I do this thing -4, so this becomes this thing. Again I cut it, and this define the -57 into 4. This one, and this one is -15 by 2, 1199. 1199 is not divisible. I could have again cut it. 11 into 4 plus 99. 99 into 4 plus 11. This one would have not divisible. And this is divisible or not. This is this. This goes to this. This goes to this, and then finally comes to 5. This itself and divided by this. The whole this number is 7001. Oh, here it is actually. Yeah. Now it comes to third order. 5. What is 599? 5999. 5999 is actually 10 cube into 6 minus 1. So this becomes third order oscillator of 5999 is plus 6 because it is minus. So we what we did, we cut 3 at a time. 3. So this plus 3 into 6, this becomes this. Again, we cut 3 at a time. This is 3 at a time, so it becomes this. This such a large number, divisible by 7001 or not. So 10 to the power 10 cube into 7 plus 1. It is number itself or divisible by this number. So 7 is my oscillator, minus 7 is my oscillator. So again, I do these 3 numbers. That is minus this thing. It goes to this one. Again, I do these 3 last 3 digits. This minus this thing. I go to last 3 digits. This one, and the last 3 digits. 21 minus this thing and 0. That means the whole all these numbers are divisible by 7001. Is it clear to everybody? The procedures? We call it third order oscillator of 7001 is minus 7. This is plus, so this is minus 7. So therefore you use minus 7 and block by 3 at a time. Divisibility by any repeat 9 numbers. That all 9999, 9999. And here I did earlier this one, so 99. It is very obvious actually. In case of 9, we just added the number. Here, since it is oscillator is repeat 9 is actually on some order oscillator. Any order oscillator is plus 1. So therefore, you just add them in group of 2. Earlier we added, in case of 9, what you did? Added all the numbers, all the digits. Here we'll be adding, but groups of 2 is divisible by 99. It is actually to make it simpler like this. Whether this big number is divisible in 999, it is called repeat 9 numbers. So we group by 3 numbers now. From right. Here we grouped in 2 numbers. In case of 9, we simply do, there's no grouping, only single numbers we add. But in case of 99, 999, 4 9s, we have to group by equivalent number of digits from right. So if this is divisible, the addition is divisible, then it becomes divisible. Otherwise, not. Okay, repeat 9 numbers are special cases where nth order multiplier oscillator is plus 1, which leads to simple addition in groups of n digits. So this I explained. Similarly, opposite of that, division by hollow numbers. Hollow number, earlier it was 10 to the power n minus 1 numbers. Hollow numbers are 10 to the power n plus 1 numbers. 1001, 1000, 10,001, and so on. So here I also group by 3 here. But like 11 we did alternative numbers. Plus and minus. Here also I do alternative numbers. You do plus or minus and then group that divisible, not divisible, and here it is divisible. Any doubt? Hollow numbers. Hollow numbers are special case where nth order multiplex oscillator is -1. And the process leads to alternative sign addition in group by n digits. Suppose we give a number, say next one, 10,001. In how many numbers you want to group, and what should we do?
And like four numbers and with
Always
alternative.
do right from right side we group into 4. Okay, because there are 4 digits after 1. It is 10 to the power 4, 10 to the power 4
4
plus
plus 1.
This number is equal. So therefore, we do alternative grouping of 4 numbers each, and we do alternative plus minus. Like in case of 11, we did only plus minus single digit. Here we do 4 digits. So 11 also is a special case of hollow number. This is also hollow number. There is another one also. Factors are also possible. So far, we didn't discuss about factors. So 421, divisibility by 421. We see that this have to be found out by factorization. 421 into 19 is 7,999. So third order oscillator of 421, like is same as 7,999, which is 8. So similarly, I didn't demonstrate the process here, but you can know that it will be done. 409 or divisibility by 489. So we find that multiplication of these two is this one, 2 into 10 to the power 5 plus 1. So fifth order negative oscillator of this number, the 2,01,000 or 409 or 489 is -2. So therefore we group them in 5 and then multiply with 2 and add them. This is the number. This number, fourth order oscillator is 3. So this, because this 229, 1, so both this number as well as 131 and 229 all will be having oscillator will be 3, and we group into 4 numbers and 4 digits, and then multiply by 3 and add. So what is the time now? Applicability of Vedic mathematics for hex numbers. Now, actually, the things are passing by, as I told, that human endeavor never ends, actually. So anytime something is discovered, so people keep on thinking and it around the alternative. Our present method is that if anybody thinks something new, they submit as a paper, and sometimes goes to peer group, and their peer group certifies it, and it gets published in as a paper. But in Vedic times, or even the Vedic concept is that anybody can add to any particular thought and do any research, and that gets to the write it as a suppose data addition, and if it is found fit, it is considered as a good one. Need to publish when we publish, like the person published a book, Vedic mathematics. Like a person can do in various ways. Even publishing paper is also no harm, but it keeps on adding the knowledge in any form. Always you may not publish a paper sometimes, but still it gets propagated. If the knowledge gets propagated, see, earlier Veda, actually people used to do meditation and then got a lot of insights, and then people used to share their thought and their experiences, and then things would progress. Always the publishing of paper was not there that time. But of course, there is in the Shruti or inside writing format, some manuscript, those sometimes it is written, sometimes not written, but knowledge goes. So there is no harm in thinking in different terms. So what is that say presently in case of computer, instead of decimal, you use hexadecimal. So just wanted to find whether it is. We found that there is no harm because the base doesn't matter really in basic mathematics. All the formula here, the Veda base is important. Base doesn't make any sense. Only the particular procedures, those are important. So I found that all the hexadecimal numbers like this, where hexadecimal numbers are 0 to 9, and then A, B, C, D, E, and F are also used as numbers, and place values from writer. This unit is oh, I didn't correct it actually. I should have corrected it. Earlier I wrote, but I left actually. So actually, what I meant is 16 to the power 0, which is not 16 to the power 1. I'll correct it later. I'll 16 square. So now say number, for example, a number 9CE will have the decimal value 9 into 256. So this is actually 256. So 9 into 256 plus 12 into 16 plus 14 at 2510. All the basic mathematics principles used in case of decimal numbers are equally applicable in case of hexadecimal numbers. And computers and mobile devices can be made more power efficient if their architectures are designed on the basis of Vedic mathematics. So has been research is already there, but it is found that by doing that Urdhva Tirjagabham, if they compared the conventional multiplication and the Urdhva Tirjagabham multiplication, they then they designed the circuit to handle that Urdhva Tirjagabham as a multiplication process in the circuit itself, not as a program. But they found that that particular circuit becomes more efficient by using Urdhva Tirjagabham instead of the conventional mathematics that we are taught from the child. And you know that not only when you are evaluating a multiplication, multiplication is used. Multiplication is all the time getting used in every process of the computer, including even your something is here it is white and here it is black. Every position here something is picture. There is in case of pictures. Even I'm writing these red things. What is getting where to be by some multiplication. All the time, lots of multiplication are going on within the computer or mobile devices. And imagine that if every step of the multiplication, if this is some small amount of time is saved or some small amount of power is saved, so many millions of billions of processing all the time is happening and billions of computer or mobile devices, how much total power will be conserved if Vedic mathematics in the background is used rather than the conventional mathematics. So, only about the mathematics I told, the only multiplication alone, only instead of conventional, it should be Urdhva Tirjagabham. So somebody did a research on this actually. So, okay. So it is not just for sake of academic interest. Vedic mathematics should be taken very seriously and should be introduced since childhood. So that is my word to say. And with that one, I want to thank you and end the lecture. Now I come to further question and answer session for any topic what so far you have covered.
As you just said, sir, because we can introduce to the new generation, like the kids who are in the kindergarten, how do we introduce this Vedic math to them? Are there any resources?
See, by propagation, for example, the motto of any Vedic knowledge or Vedic in general and Vedic mathematics in particular, one should be, suppose I gave you this procedure, I taught you this procedure, but equivalently, you should be prepared to some that extent that you should be able to propagate also. You should be able to teach. I think There are some people who can teach these things, no? I hope. Some practice is required, of course. How many of you can now, so for example, take a class of, say, this one, say, recurring decimal? Get confidence. No, there is nothing so great about it, really. Only thing is that we are not practiced to think that way. And in kindergarten, as you mentioned, any child, fresh student, their brain is fresh. The time they will take to learn the conventional multiplication, they will take the same time to learn Urdu Tijja Goutham. There is no difference. It is only a change in the point of view and change in the procedure. That's all. Maybe this particular mathematics, it will be learned, say, the higher class when we get binomial expansion and so on. But the procedure wise, just multiply this thing and by do the by doing a carry and this thing just by remainder and quotient and remainder of each small digits. This procedure repeated. Of course, this is actually slightly 7 or so, but I don't think that this one, for example, the division. The division will not be difficult, I think, for 7 or 8 standard students. I don't think it will be difficult.
Yeah.
Okay. This multiplication. This multiplication we are teaching. In any case, people are learning, I think, in class 3 or 4, isn't it? Or before that. One can only do in slightly changing that. It actually here actually also, instead of multiply everything, you just do corresponding digits and cross multiplication, and they may also do something. I mean, they don't have to remember 1 into 2, and then here, for example, 4 into 2 plus 1 into. Then write that it is 4 into 2 is 8, 6 into 6, and 3 plus 3 into 4 is 12. Okay, and this is 26. And we write 6 here, below this, middle of this, we write 6, and 2 here, 26. So when some person can do this one, some person can do this one, multiply everything and writing below and adding. So why not this also can be added this way? Tell me. There is nothing different. Somebody is learning that one also. This one somebody is learning. Okay, parallelly, or this one only exclusively, doesn't matter. Of course, this is most general. Don't have to think much actually. Although sometimes it will be a very huge process, and so therefore the Vedic mathematics will do alternative ways. But there is a general way you can say that it will sort of never fail as it. But never in a case will be there where it is difficult but not applicable, you cannot say. But Vedic mathematics sometimes, as I told, that sometimes it becomes it gets complicated. But even expert will tell, no, it is not. With practice also, it can be as easy as the conventional ones and applicable. Any more question?
Actually, what I see is at kindergarten level or even class 1, class 2, till the student starts addition, subtraction, probably the Vedic mathematics also deals with the same number.
Yeah.
Same numbers. Numbers up to numbers is a common for kindergarten or first or something like that. When it comes to say addition, you are finding better ways in Vedic mathematics.
That using the vinculum. That is the only thing.
So this can be introduced even starting from kindergarten.
So experiment has to be done with how the children are learning from beginning. Before that, it has to be added in the course, because if they learn this way, and then suppose in the class they are told that no, you cannot do this way, then it will be, although result they get nicely, but in the intermediate steps, that teacher, if they do not absolutely appreciate it, there will be a problem again, isn't it? So
That is true, Goutamji. Actually, I faced this problem with my daughter when I introduced this. You can have an easy way to multiply, do this. And she said, if I don't show the steps of how I got this answer, my teacher will not appreciate it.
that becomes a problem actually. So this mental framework has to be changed even for the education makers. I think now gradually, I don't know, time will come probably. Time is maybe coming when the seeing that discriminating from the conventional with Vedic. Because I told that everything can be called Vedic also, and everything can be called workable, working. So why to distinguish this conventional, which is running for some few maybe centuries, recent century, 200 or years or so, few decades, you can say. Why to distinguish those things with the other procedures, that keeping only focusing on only one procedure, even if it is not efficient? I don't understand any logic behind that.
Yeah, I think some universities have already started introducing this as a subject. I think it will spread.
Spread. Introducing some procedures should be from childhood, as you're telling. I should come in the total culture that okay, this is that these things and so on, because those things are on a school level. Actually, these are many things are school level things. Only thing is that we never thought in that, but we never learned that procedures from school. Explanation are there all the time. Explanation may be slightly of higher knowledge is required slightly, but there will be procedures can be learned as we learned in the procedure of other things.
And to add to that, I think technology is the leveling factor here, because as a child, I wanted to learn this, but we did not have a resource in my hometown to teach us this. I got a book when I was a child from the railway station back then, but I could only read the first chapter. After that, I could not understand, and there was nobody to explain it to me back then. I always had the book, but as a child, I could not. And but now with the internet, if we have the videos, if we can come up with small tutorials and videos or anything like this, anybody who is interested, they don't need to have the teacher in the same town anymore, be it for Sanskritam or Vedic mathematics. Now, as long as the zeal to learn is there, we have avenues to just propagate it to whoever is interested.
Right. Now, in some cases, I've heard that there is somebody comes learning the Vedic mathematics and gave a sort of popular lecture in schools, and people appreciate, then forgets. That is the thing. They will appreciate, but since it is not in the curriculum, interest got fade away. That is the thing.
So in this group, is there any interested to join hands to do a small thing, like each one of us can master one piece of it and then probably come together to make a small course? It need not be elaborate, but if we can come up with something like 10-day thing or anything like that, each one of us can take one topic, master it, and kind of teach kids
teach some start teaching some students. I started teaching this Vedic online method of question and remainder, and whoever I taught it found they got interested, and they started within 2 minutes. They learned, and the next step they're telling themselves. There is nothing wrong actually. There are six standard student, 7 standard student. I tried with all up to 11 standard.
I think whatever you have given us is definitely a wealth of knowledge, and with this impetus, I think we will also carry it forward, pay it forward
Yeah.
by practicing more before we giving it to others.
So, instead of taking a class like this, you may not be confident that much at very beginning. But what I want me to say that this you can start teaching to school level students, and let us see what the reaction is there, how fast they capture that thing, and so on. This will be a good thing actually. Your own in the family or in the neighborhood and so on.
This is easy to capture also.
My brother is actually teaching with mathematics
Whom?
through a small company called Eritis. So they teach both abacus and the Vedic mathematics. So it is going on well. There is a lot of the plan here is that teaching the teachers. So training the teachers. So I think he has a model where he's identifying different people who are interested in teaching children and imparting this knowledge to the different teachers, and they're doing with abacus and also Vedic mathematics. Both are being taught to a lot of children. So that is kind of successful. So we can...
abacus particularly, I never heard. Somebody told that this is certain things are similar to abacus. Is it? You know abacus?
I don't know abacus, but I think they are probably two different things. I'm not really sure about the details. But one thing that he is doing is it depends on the interest. Some people may be interested in abacus, some people may be interested in Vedic mathematics. So whatever they want to do, they are doing it.
Yeah, my daughter, she learned when she was learning abacus, I could see that whenever they have to count 9, they always takes like 10 minus 1 like that. So they always like goes with the easy ways to figure out the easy calculation. So it's like even if it is 8, then it is like 10 minus 2. Though, so it was it's a little bit similar to what we have.
Yes, it is as if sort of vinculum. Sort of vinculum actually.
Vinculum, yeah.
It's absolutely mental, completely mental, mental math.
Yeah.
They are trained for mental math. Yeah.
So, Gopal Krishna Garu, could you please furnish those details in the chat today, Andy?
Definitely, Andy. I will let you know. I think I didn't get your name. Can you?
I'm Praveena Jayanti.
Sure, Andy. I will let you know about it.
Thank you.
Thank you. Sure.
Here, there is another way. I have seen people, the Vedic mathematics itself, instead of like I expressed this as vinculums, additions, they also did instead of 10, this did with 9. It is also another way is there. Another way is there. Addition with 9. If something is adding to 9, then this is 9, for example. Then again, you 6 plus 2 is 8. 8 plus 4 is 12. And then they're dividing by 9. There is some way actually. The 3 becomes extra, and then with these 9s they do and something. Some kind of thing is there. I think it is similar to abacus. This may be similar to abacus.
One little thing, Andy. I see Padmaja Raymond Garu on this group, in this group. So are you connected with Raymond Avadhani Garu, who is also into Vedic mathematics? He has written several books on Vedic mathematics.
Yes. She is, distantly related.
Oh, I see. Okay. That's nice, because I have some books of Vedic mathematics from him. So
yeah. Can you share the that books and or his numbers?
Sure. What exactly you want me to share? Just the name of the book and
this particular writer's number, contact number, or so that we can those who are interested or advanced or written a book, they can be all together. They can be considered, and then
I'll give you
a good knowledge base can be there.
Sure, absolutely. I will share the details, whatever I can. Sure.
To my number that I wrote it.
Sure.
Okay, I think we have completed this course on Vedic mathematics.
This is my email number, and this thing, email and contact number. Kindly share it. Please, yes. Please continue, sir. Yes.
So let us all thank Guruji for, he has taken painstakingly also prepared a PPT for all of us. It is a special course for us because he has done a lot of work. In fact, he taught us in the first course also. And now, in fact, whatever he taught is much improved version of, the PPT itself has got a lot of changes. So definitely, yes, there has been a lot of hard work gone into this, and let us all thank Guruji for.
Thank
Absolutely.
you, Gautam.
Thank you so
Thank
much,
you.
Gautam ji. I think
Thank
it was
you,
really,
Gautam,
really.
sir.
Thank you so
Thank-
much, sir.
Thank you,
And we
Gautam, sir.
appreciate
Thank you so much, sir.
Thank you, Gautam sir.
Thank you, sir.
Gautam Guruji garu, thank you chala.
And thank you all so that you had a patient hearing my lectures. Thank you.
And we look forward for the advanced course.
Basically, I am a maths teacher, maths
Oh.
and physics teacher. I retired as vice principal of Madapati Hanumantrao Girls High School.
My God, yes.
So this maths is very much interested, and I'm going to introduce in my school at least for small kids,
Yes.
primary, because I'm in charge of primary section also.
Okay.
Okay.
Thank you very much, Andy. Chala bagundi.
Welcome.
Now I know Anantanji is getting prepared. I'll request him to wait till. Thank you, Guruji, Gautam Guruji.
Thank you.
I request Anantan Garu, don't start your prarthana. We need to take test. So all of you are ready. 61 people are there on this thing. So I put the link in the chat. If you double click on that, you will get a form, which I showed you some time back also. So you follow that and answer all the questions and submit it. Okay. So shall we start? The moment I give the chart, the time starts. Maybe you take 1 minute more. That's all.
We can do it on the mobile phone also, hopefully.
Yeah.
You can stop recording and start re-recording. No, otherwise Vedic mathematics will be.
Anilji, shall I stop recording?
I think we can stop recording.
स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण मणिमैषाः ओ ब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवीसस्यशालिनी देशोऽयं क्षोभरहितः ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अधनाः सन्तु जीवन्तु शरदान्तकम् सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतङ्गमय ॐ शान्तिः ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्तिः हरिः ॐ श्रीगुरुभ्यो नमः हरिः ॐ
Chittipappu garu, ధన్యవాదాలండి అనంతన్ గారు. Chittipappu garu, I think you are okay.
Yeah, you have to tell me okay or not.
Okay. Let us do Janigan.
Fine.
Yeah.
There is disturbance coming from others. Others are to mute.
No problem. Don't worry. Go ahead.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्ज्वल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद
Jai Hind.
जय हिंद।